Welcome back to the series of HRMAn tutorial videos. In this video we'll show you how to actually use the analysis pipeline itself. If you're interested in setting up HRMAn and training it, you can watch all the other videos that you can find on our homepage HRMAn.org. This video is going to have two major parts based on the two different analysis types that are currently available in HRMAn. And for the sake of this tutorial, I have created a folder with some example images that we're going to use for the analysis. So you can see here the images, they were recorded a while ago already. And in this experiment we have infected HeLa cells with Toxoplasma gondii, and we stained them for ubiquitin. So we were interested in the levels of ubiquitination of Toxoplasma vacuoles, and this can be quite easily analyzed with HRMAn. So what you need for an experiment like this obviously is your images. You need a training data set for the replication prediction, and you need a trained neural network for the recruitment analysis if you want to perform recruitment analysis. There's also a truncated version of HRMAn that doesn't analyze recruitment but analyzes just the infection and will give you fewer readouts, but it's enough to quantify infection in quite high details. And if you have all of this in place, you're good to go to use HRMAn to analyze your images. So in our case here we have images, a couple of them from two different wells. One is well C5 and the other one is well E4. So let's pretend that for this tutorial that these two wells represent different groups. So the first thing you need to do is to adjust your plate map. So in this file you can see the wells, and then you can tell the program which well belongs to which sample group and if the well has been infected or not. So I've already prepared this. You can see here I told the program that well C5 is sample group 1 and was infected, so you just put a 1 here, and well E4 I'm going to pretend belongs to another sample group, so this is number 2, and it has also been infected, so that's why there's a 1 here. So we can close this and save it, and then we can get started using HRMAn. So if you go to KNIME, you can open the workflow, and a couple of things you need to provide. So first you need to upload your images. The way you do this, you double click onto this node, which will open this dialog box, and here you can browse to the location of your images. So in my case, they're in the desktop, tutorial data, example images, and you always have to select the directory, not the individual images. So let's go back, example images, choose. Okay. Next thing, you need to provide the plate map. So same thing, I'm going to navigate to my folder where I saved the tutorial data and select the plate map, choose it. And you can already see a preview here. So if you remember, well C5 belonged to sample group 1 and well E4 belonged to sample group 2. So the program has read the CSV file and will use it to cluster your data. And the third thing is the learning model. So for this you need the annotated file that contains the information on your pathogen vacuoles. So I've got this in the training data set. Click OK. And the last thing is the recruitment model. And in our case, this is an AlexNet model that we've trained specifically for Toxoplasma infection and ubiquitin staining. And once all of this information is provided, you're good to go. Now we're going to start the actual analysis. And after we have provided all of this information in the nodes here on the left, we're now going to do a simple infection analysis experiment. So you can just select this image viewer and execute the node by clicking the little play sign, and this will lead to execution of all the previous nodes and start the analysis pipeline. The first thing HRMAn is going to ask you is how many channels you use to image. For infection analysis, you only need to image 3 channels, which is the cell nuclei, the cell's cytosol, and your pathogen. We did the same thing here, so it's 3 channels. Then you need to provide the channel order. And I know that the first image in our case is always going to be the nuclei. The second one is going to be the pathogen, so we'll put a 2 here. And in channel 3 we can see the cells, so we're going to put a 3. So HRMAn is going to double check with you if that is correct. If it is the case, you can click yes by putting a 1 here and clicking OK. Then he will ask you for the magnification you use to image. In our case we used the 40x magnification, and we infected the cells with toxoplasma. HRMAn is also set up to work with salmonella, and in the future we're looking into expanding this range of pathogens to others as well. And this information, together with the size of the images, which is automatically extracted, and the magnification used to image, will automatically adjust the filters so that your data quality will be optimal. Let's click OK here. And then the last thing he will ask you is which analysis type you want to use. So at the moment it's set up for 3 different analysis types. 1 would be infection analysis, 2 would be colocalization analysis, which at the moment is still under construction, so I would not advise to use it. And the third one is recruitment analysis. And in this example we're just going to do infection analysis, so we'll put a 1 here and click OK. Then he will double check with you again what you've provided as information. So we want to perform infection analysis of cells infected with toxoplasma, and the microscope magnification we use to image is 40, and that is correct. So we'll put a 1 here again and click OK. And then, because now the actual analysis will start, which might take quite a while if you have a lot of images, he just double checks with you if you provided the correct plate map. And we did do that, so we'll put a 1 here and click OK. And then the analysis is going to start, and you can follow it, and all the time something has been done, and the little traffic light will change its color and, for instance, jump to yellow or to green. And now the first part of the analysis was successful, so we can take a look at our images using this node. So we can right click on it and select View Image Viewer. This will open a table in which we'll be able to see the images that we've provided. So you can see here we've got the nuclei, we've got our pathogen toxoplasma, and we've got our cells that were stained with ubiquitin. Then, to see what HRMAn did, we can have a look at the labels of the nuclei. Again, right click, select View Image Viewer, and then you can see your nuclei labels. Similarly, you can have a look at the pathogen labels. So again, you can open this context and you'll see the image and the resulting labeling that HRMAn has created. And this is actually what the computer will see. And the last thing, we need to segment the cells, so we can also take a look at them. View the image viewer, and you'll be able to see your cell labels. Now, in this particular case, you can see all of the cell labels, but actually all of the labels that are touching the border, so for instance this one, this one, this one, will be excluded from the rest of the analysis, because we don't know what happens outside of our field of view, so this might skew your results. So once you're happy with all of these labels, you can select the XLS writer and execute it, and this will start all of the calculations, and in the end write an Excel file to your hard disk. Now we can see the analysis is done, so HRMAn will tell you what he has done and which outputs you can expect. So you can click OK. And the last thing he wants to know from you if you want to add a scaling factor between your pixel size and your actual sizes. So let's do that. In our case, I know that 1 pixel translates into 0.21 micrometers, so I'm just going to click yes here. I do want to add a scaling factor, and then I can provide the value of 0.21, and this will then adjust all of the outputs and change the dimensions from pixels into micrometers or square micrometers respectively. Let's click on OK. And once the analysis is done, an Excel table will open, and you can now have a look at the data HRMAn has produced for you. So we've got our 2 sample groups here, sample group 1, sample group 2 in the second row. And the first thing you will see is some information on the pathogen vacuoles, so the area, the error, circularity, perimeter, fluorescence intensity, and the number. Then we can have a look at the replication, which was classified using the decision tree. So you can see here 80 or 71% of all vacuoles contain only 1 parasite, and the others contain either 2, 4, or even more than that. And a bit easier is the percent replicating. Then we can look at the pathogen load, which is the ratio between all of the parasites and the cells. We can have a look at the vacuole to cell ratio, which is the ratio between the vacuoles and the cells. We can look at the percent infected cells. Here there was no error calculated because, of course, we only imaged 1 well, so we did not have any replicate conditions. Then we can have a look at the detailed infection levels, so uninfected cells, then cells that only contain 1 vacuole, 2 vacuoles, 3 vacuoles, and so on. And we can have a look at the positioning of the vacuole, calculated as the mean Euclidean distance of the vacuole to the nucleus of a cell. And these are the outputs that you can expect from a basic infection analysis. Now let's do a recruitment analysis. So as I told you earlier, our cells were stained with ubiquitin, so we can use these images to analyze how many of the toxoplasma vacuoles get ubiquitinated. I haven't changed any of these nodes, so they still contain all the information as provided before. So we can just restart the analysis as done before. So again, we need to answer the questions. We imaged 3 channels. The order is first channel nuclei, second channel pathogen, third channel cells. That is correct. We imaged with 40x magnification, and we infected with toxoplasma. And this time we want to do recruitment analysis, so we'll put a 3 here. And that is correct. We provided the correct plate map. So now again the analysis will start. And we can have a look at our images again, so you can see it's the exact same images as we used before. Then we can again look at the nuclei labels. You can see segmentation is the same. Then we can look at the cell labels. So let's execute this node. And as you can see, we have the same segmentation as before. And now we just need to wait for a bit for the pathogen labels. And what you will see in this case, if you choose to do recruitment analysis, is that you not only get the segmentation of the individual vacuoles, but you'll also get a region of interest, which will be used to analyze the recruitment. So this is just the deleted version of these labels. And if you're happy with this segmentation as well, you can again execute either the XLS writer, which will then write the data, or you can first take a look at the resulting classification. So by executing this image viewer, which only works in the recruitment analysis, you'll be able to see which vacuoles HRMAn has classified as recruited. Now let's take a look at the result. And here you'll see the images. For instance, if we look at this vacuole, if you go to the RGB image renderer, which will show you both channels at the same time, you can clearly see here in red the Toxoplasma parasite, and in green the ubiquitin staining surrounding the Toxoplasma vacuole. If you're again happy with this result, you can trigger the rest of the analysis by executing the XLS writer on the right hand side here. So while the rest of the analysis is running, I can quickly explain to you how you can use the image writer node to export example pictures of the recruited vacuoles. So you can just double click on it, and this will open again this window in which you can configure it. You can choose which image you want to save. In this case it's recruitment for the staining 1. You can browse to a location where you want to save the images. So let's say we just want to save it here in the tutorial data. And you can choose a file name column. In our case it's best to just choose the row ID, and you can select from a whole range of image formats. Of course the best one would be TIFF and uncompressed, as it's not going to change your images. And then you can just OK this and execute the node. And if we now look at our results table, so once the analysis is done, HRMAn will get back to you again with what he has done and which outputs you can expect. Let's click OK. He wants to know if we want to scale the images again, so let's this time not do it. So I'm just going to put it 2 as no. Click OK, and then this will open the results file. And as seen before, for the simple image analysis, you get the same readouts. So you get, again, information on the toxovacuoles, you get information on the replication here, you get percent replicating, the pathogen load, the vacuole to cell ratio for our 2 conditions, percent infected cells, the infection levels. And then on top of that, this time, you also get percent recruited vacuoles. Per condition, you get the mean intensity of the coating surrounding your vacuoles. You get the mean radius as defined as the distance between the centroid of your pathogen and the coat. You get the maximum intensity. Then, because your data is then grouped into recruited vacuoles and non-recruited vacuoles, you get the replication prediction just for the recruited vacuoles and just for the non-recruited vacuoles, so you can compare them against each other. And a bit easier to see, you get the percent replicating for the recruited and the non-recruited vacuoles. Then this readout will tell you how many vacuoles on average one cell decorates if she contains more than one. This readout will tell you how many infected cells do respond by recruitment, and in the end you'll get the distance to the nucleus. So those are the readouts for a full recruitment analysis experiment, and I hope this tutorial was helpful for you. If you want to find out more, you can have a look at our homepage, HRMAn.org, and if you have any questions and comments, you can also find contact information there. I hope you enjoyed this video, and I hope this contains some information that is useful for you so that you will be able to use HRMAn for your image analysis. Thanks for watching and see you next time.